There's 3 of them here that we're going to talk about today. You have quite a few of them around the plant here and other plants here for Inland Empire. So I think most of you guys, I know Tim for sure has rebuilt them, probably knows more about them than I do for the internal workings and how to adjust them and things like that better than I do. But we're going to go through some things. I have a cutaway here, so please feel free to ask questions or make comments or whatever you guys see from an operational standpoint. Here's some general brochures. It's on Vaughan. On the chopper pumps, I see you have the books as well. If you want to pass those around. Anyway, we're going to talk about the horizontal chopper pumps that we have. These are the 3 units here. They're sludge transfer going through your heating system here. That's why they're jacketed to keep the heat. And just working off the digester here. Is everybody pretty familiar with chopper pumps, how they work, and how they work, you know, what they're all about? I got a cutaway here. If you have any questions, please feel free. But the whole idea is this pump is made to chop and cut the rags, the plastics, whatever solids get in there. This is what the suction of the pump looks like. You have a cutter bar here, and as the impeller is turning, you're shearing everything as it comes into suction. So the idea is not to have rags or plastics pass through the pump like most non-clogs, but they'll actually get chopped up here at the suction area. And the tolerance here, shear all the solids right coming in here at the suction. The idea is that the area up here in the front, the impeller is set 10 to 15 thousandths on the clearance between the cutter bar and the impeller. And that's where your shearing happens, right here at the suction. And basically as rags come in, they're reduced in size down to about 1/4 inch in size. No matter if they're big, large, we don't care if they're a 4-inch or a 5-inch solid, like some of these non-clogs are rated for a 4-inch solid. Basically they come to the suction of the pump, they get chopped up and then pumped on from there. The impeller is made of a tool steel, hardened. It's 65 Rockwell, so we're trying to be as hard as possible without being brittle. So if you hit rocks or sand or whatever, you want to last as long as possible, but not be brittle where it's going to crack or shatter if it hits something metal or a rock or whatever. The backside of the impeller, where you tend to get more of the rags and hair, the finer material coming in and trying to wrap around your shaft, we have what we call an upper cutter here. Again, as the impeller is turning, we'll be chopping and cutting the material on the backside, moving it back into the casing, and then pumping it out. The upper cutter protects the mechanical seal and bearings in the shaft. And then we have a mechanical seal, which these have a mechanical seal that's flushless, which means there's no water, which is a little bit different. It's new and improved, where most plants are trying to reduce their water for the flush or for the mechanical seal areas. So these are flushless; they don't require any water at all. They have a cartridge type seal with an oil cavity around it that's self-cooling, self-lubricating. These have been out about 3 years now, and they've worked very well, very little on warranties and repairs. So on these pumps here, you won't see any water flushes, any water lines going to the seal area. And that's becoming pretty much the standard now. Most plants are wanting flushless seals. And on the backside here, just like Tim has seen on the other pumps, they're all oil bearings, oil lubricated bearings, radial thrust bearings, rated for 100,000 hours.
So you guys don't know yet what the lifespan is on the seals?
On those new seals, they've been out 3 years. We have locally here about maybe 250, 300 seals. We had one go out last year on a warranty. So, but 3 years so far. Long term, you know, they've been out in service, like from a R&D standpoint, almost 5 years. So it should be long term, just like the other mechanical seals. They're still silicon carbide faces, stainless steel materials. So they should last a long time, but just like our other seals, just different lubrication for them.
Are those seals, do you have like training on installing the seals, or is it something that more or less the Vaughan installs, or how do you do that?
But they're a cartridge seal like the other ones. They're pretty much a cartridge, one package that slips in there. On repairs, we offer send them back to us and we'll rebuild them and send them back to you instead of you going through the parts. But there's silicon carbide bases, which are pretty standard out there, and the program is to send them back to Vaughan. Now, since we've had very little on repairs, long term, whether you want to do it on site, I'm not sure what's going to happen on that.
Vaughan warranty it?
On warranties, yes. Yeah. There's a standard 1 year workmanship, parts, materials, whether it would be those or the other seals. And Vaughan makes these seals. It's not like they're buying it from Chesterton or John Crane. Vaughan makes these seals themselves. They're made so the shaft will flex a little bit as you're chopping through material. There'll be a little deflection, so it's not your common seal that you can buy off the shelf anyway. Now, the one difference besides the mechanical seal on these pumps versus our other pumps that you have is that the adjustment on these in the past has always been with a shim set. Take off the cutter bar. If the impeller's getting worn, you might, when they come out of the factory, they're at 10 to 15 thousandths clearance at this level right here, where you're shearing at the cutter bar and impeller interface area. The old system was shims. Take off the cutter bar, take out a couple shims, close up that tolerance, and you're ready to go again. That meant opening up the suction manifold, getting in there and pulling out the shims. The new system now, and I'll show you on these 3 new pumps, is there is no shims any longer. The adjustment's done on the outside, behind the casing. And it's called a back pull-out design, so you'll loosen up the 4 bolts on the back side. There's jacking bolts that will push the whole assembly, the impeller, towards the cutter bar, close up the tolerance area. What you do is you go all the way down to the cutter bar faces, and then back it off 10 thousandths. So everything's done on the outside. You don't have to get in with the sludge. You don't have to worry about any contamination or anything like that. Everything's done on the outside by the casing. And I'll show you where the bolts are on the hole pattern for the adjustments. But that's one major advantage, makes it a lot easier on the maintenance side. Nothing on getting inside the pumps and dealing with the sludge. And that's true for all the new pumps. That's been out, again, another 2 to 3 years it's been out. Everything else remains the same. Impeller, cutter bar, everything like that. It's just easier to adjust it. Any questions on this cutaway here or on the pump itself?
Yeah, I have a question. Doesn't pertain to this one, but the dairy digester, we have a 6 and an 8 pump over there.
Yeah, the verticals.
Yeah.
Yes.
And now they change it to be is that a 4-inch. Do you think that's going to last for the material that they're going to use that for?
Well,
because that 6 and an 8, we have a problem with the 6 and an 8 already.
yeah.
Now
Well,
they change it to a 4-inch.
That's another subject here, but I can tell you that what we recommended to the engineers, the bigger pumps turn, or they're bigger materials. First of all, there's a lot more meat to the materials because of all the grit and sand and mud, rocks, everything that was in that dairy area. We recommended bigger was better because they run slower. And the faster you turn something, the faster it's going to wear out. The 8-inch pump they initially wanted 6-inch pumps. We recommended 8, and they put 8-inch in there to compare against the 6. The 8 does a lot better, lasts a lot longer because it's even turning slower than the 6-inch pump. It just comes down to how much metal you have there and how fast you're turning it. The 4-inch pumps are turning, I think, 1200 RPM. The 8-inch pump was turning like 700 RPM. So I mean, you're almost talking 50% the speed. Usually speed, you double the life of the parts when you put on the speed. So if you're half the speed, you're going to double the life. And they decided they didn't want to do that. So I'm not sure, we try to show them we can do the same flow, same pressure with a bigger pump, and it'll turn a lot slower. It's going to last a lot longer, and they said no, it's going to be an easier service. That was their design, and we made our recommendations. Okay. So on that one, Tim, I can tell you for sure we were saying this is going to be a wear item. I mean, you're looking at a smaller pump here, and it's going to have to turn faster to get you more flow. And they said, don't worry about it. We got this thing all sized out, designed right. It's going to be easier service than the other ones. Not our call on that one. We gave them all kinds of, say, take this design. It's not that much more for an upgrade to go to the right size, and they still didn't want to do it. So I hope I don't get myself in trouble on tape here, but we made our recommendations, and that was their choice. But bigger pumps, that 8-inch pump's it's a big pump, especially compared against that 4-inch.
Yeah.
And it's quite a bit bigger than that 6. And it's strictly just trying to make it last longer. I mean, we do lots of dairies, pumping that material, and it's so thick and it's so abrasive. It's not hard to pump it. It's just very abrasive with all the material stuck in there. It's a lot of rocks.
Yeah.
Now things, you know, when they first put them in with Synagro a couple of years ago, I mean, there was, you know, we saw like rebar going through there, wood, you know, dead calves. They had all kinds. They had, you know, not the 2x4s, but boulders and stuff. I mean, it was tons of gravel that was going through there, just wearing the heck out of them. And they've cleaned it up through the years. I know they've screened it off a little bit, and they're accepting less material from the dairy guys, but still, it's a bad operation. I mean, tough operation. You know, it's a very bad area. It's very tough on equipment.
Oh yeah.
Doesn't matter if it's our pumps or anybody else's. It's going to be tough on equipment in general.
Right.
But that 4-inch, that was engineering's design. Okay. Any questions on the chopper pump or new? I'll show you these new ones right here. We already ran them. Everything checks out. They're only doing water, so I'll come back in another day when down the road when you have sludge going, because the pressure on the gauge is a little bit lower. Just pumping the water, which is true. I mean, the sludge will cause the line losses to go up a little bit. If you want to take a look at this pump right here, I can show you. Just flush the seal area. You won't see any water flushes, no gauges, anything like that. Not much to look at inside from this side of it. Looks like any mechanical seal with the gland, but there is no water flush. You'll see one little threaded, there's 2 ports in here, and that is for the oil that they fill at the factory. You don't have to worry about touching those at all. If you ever replace them, then we would open them up, fill it with oil, and then close it up. But there's 2 ports on top, one on top and one on the bottom. There's no maintenance, there's nothing to do. The casing, they've redone the back power frame. This is a bigger casing than the old ones. Still the same shaft and bearings in there. This is the back pull-out design right here, where you have a interlocking bolt system. You loosen up the outer bolts, and then this is the adjustment for pushing the whole impeller and assembly towards the cutter bar, and then you tighten this back up and you're good to go. There's a, let's see, 2, 4, 6, 8 bolt hole pattern here, so you basically go in like a star pattern, one here, one there, and one down here to evenly go up against the cutter bar, and then back it off, and then you adjust all the other bolts to tighten them up. But the idea is you leave the suction, you can't really see it here, but you leave the suction and the discharge in place, and everything's done from the power frame and back.
What temperature rating do you have on this? Because it is going to be on the hot side.
Yeah, these are, you know, we're doing the refineries and the food people, and they're up around 220 degrees, so you're well below what we would be pushing these seals and materials.
Spec out at what, a 160 or?
I was told 160, so I mean, sound like on the high side, maybe 170, 175, but we're well below where we have to worry about anything from a pumping standpoint or seal.
180 plus.
Other than that, this is the motor stool, which is self-aligning. The motor, coupling, and the power frame are all self-aligned with the motor stool. It's got a Woods coupling inside, and a standard Reliance motor here on the back side. 10 horsepower, 1170 RPM. So these are turning pretty slow to begin with. They should be nice and quiet, which we checked them out. Can we fire up either one?
Yeah, that one's got one. Well, hold on, let me turn it off on the inside.
Those aren't explosion-proof motors, right?
Let's see.
Class ones.
I think, yeah, they are. XEXs are explosion-proof, severe duty.
Are they variable speed or just one speed? Or?
These are variable speed rated motors, and the pumps are for sure you can run them any speed you want. They're set up for like direct drive, but you could definitely slow them down, speed them up with a VFD.
Oh.
Any questions about the pumps themselves, or I know you know them pretty well, but not very much from a difference from a overall standpoint, except for this back pull-out design. Yeah, which would be a lot better from a maintenance. Everything's done from the outside now.
Yeah.
But Lovejoy is fine. Whatever style is the standard. Sureflex. Ready? Sure. We checked them out for no vibration. They sound pretty quiet. They should, since they're only turning 1170. They're pumping, supposed to pump 350 gallons. They're pumping about 400 since it's water. pressure's a little bit lower than it was designed for, which again is pretty standard because of the water. It'll go up a little bit, and I'll come back and check them out once you get sludge going through them. That's pretty much it for from a pump standpoint. You guys have any questions or?
You know their
How many did,
operational plan? Are they planning on running? You have two units for trial plan for a bit of time. One standby.
One's the spare. That's my understanding. With the two digesters, one each. They'll go. I think they're going 24/7 once you're up and running, and then one is the spare. That's my understanding from design wise.
I think from quick number showing either or tonight. It's like everything.
Now these are pretty much interchangeable. With the other pumps you have, the other digesters are the same size. The only thing is that they are not back pull-out design, but the impellers, the bearings, the shaft, everything else remains the same. There's a lot of interchangeable parts.
Really?
Yeah. The casings are different because you can pull these ones out. So the impellers though, and shaft and bearings, there's a lot of common parts between them. Mechanical seal will be different, casing's different. There's one additional part now, it's called the back plate, which is this plate right here. Instead of the casing, the loop being one piece, it's now got two pieces. But the upper cutter's still the same. There's a few O-rings, there's no shims now on the front side. Instead of a shim, there's O-rings that seal between that suction manifold and the cutter bar.
So most of all the internal parts of this can be used for the one that's
A lot of them, yes. Yeah. The only difference on those have been here like about 7-8 years, so these are harder materials than those. I mean, these are 65 Rockwell, those are about 58. These are a little bit harder. The impeller and the cutter bar are a little bit more efficient, as time goes along they make improvements. So efficiency-wise, those would be, they used to max out about, say 59, 60%. These are up around 68% for efficiency. So they're a little bit, you're gaining 3-4%, depending on where you're at on the curve, all the way up to almost 10% design-wise. So a little bit more efficient on the motor side, it could be more well ahead. Right. But that they are the new parts will go into the old pump cell. So there's interchangeability there. And that's true for those over there, and they have a couple over here in the sludge, at the primaries. Those are the same size as the ones over. So they're all a common size. They're all 6x4 inch pumps. Just to let you know, we do have some other pumps here. I mean, you have some submersibles, there's different units, like you're talking about carbon canning. You have some vertical pumps over there. Whether the submersibles or verticals, the horizontals, they're all basically the same kind of pumps. They still operate with the impeller, cutter bar. It's just a matter of how do you mount the motors. Are they submersible motors or the horizontal motors? At some of the other stations, you have some pedestal mounts where the motor's up on top. They're still the same pump as this. It's mounted vertically. They have a smaller footprint. But the pumps themselves are all the same. And how they work, and what they're doing there, chopping and cutting up the rags, plastics, they all operate the same. At RP1, they have some bigger sizes. They're up there on the 8-inch pumps. Well, you have the vertical one over there at Chino, the dairy one. The 8-inch, again, they're common. These ones are RP1. The only thing that's maybe a little bit different is Vaughan offers smaller sizes through the years. They go down to 3-inch pumps, and they go over to 12-inch pumps, like the high-rate mixing pumps with digesters or pump stations or headworks now. I mean, we're in the different areas where we have a lot of solvents. Basically where they're at. Anyway, the books you guys have there that we provide from contractor, that's basically got everything, parts, breakouts, part numbers, the curves. Motor specs are in there for Reliance, all the data and the windings, all of those things are in there. Coupling specs are in there, bearing specs are in there, so everything you want on these pumps are in those books.
Like you modified the adjustments on the couplings, stuff like that for alignment.
Yeah, the actual footprints on these things are quite a bit smaller for the feet as well, and you can adjust those as you move. If you're pulling back out, you can actually take them off and it slides right back. the whole guts of the pump will come back. You leave your suction and discharge in place. So for most people, what they'll do is they'll isolate, you know, the suction and discharge, bleed it off, and then they just pull the pump out, and you can get into the whole pump, or just take the motor off and take the pump back to the shop. So it makes it a lot easier. They're trying to improve things from the maintenance standpoint, make it easier in the field. Yeah. So once you get sludge up and running, though, you let me know, Tim, and I'll come back out. We'll check out the pressure, do an amperage check on the motor, see how they're running, make sure they go through, everything checks out there.
You did the plumbing to this. These are all plumbed one to each
Plumbing,
digester?
are you calling us plumbers?
No, he's a ditch digger. You don't know plumbing.
You mean the piping?
Yeah,
Say it again, what was the question?
the piping. How is it? Are you able to plumb? Send this one to digester 4 or this one to digester 3. Yeah, that option.
No, the off-deck panels, that's over there. That's in your the boiler room. Where they're sending it, I really don't know. They don't even know,
Just sludge.
to be honest with you. They're still working on the design.
So I'm just saying, say for instance we get this one to fail, are we going to be able to
Yes, it'll.
pump
That's
the,
why they
the
have
other
the
one?
3. You're definitely got it back. That's why you got the 2 exchangers also. You have 2